Good day everyone, I'm Ma'am Jen and we will be discussing triangle inequality theorems. But before that, let's have first the objective of our lesson. At the end of the lesson, the student should be able to apply theorem on triangle inequality to determine possible measure for the angles and side of triangle. So let's have example number 1. Consider the figure below. We will fill in each space to complete true inequality statements. So now, we will apply here the exterior angle inequality theorem. So the measure of an exterior angle of a triangle is greater than the measure of either of the two remote interior angles. Angle A here is the exterior angle. Angle C and angle D are the remote interior angles. In exterior angle of a triangle theorem, so it says that the sum of the remote interior angle is equal to the measure of its exterior angle. So we can say that the measure of angle C that plus the measure of angle D is equal to the measure of angle A. Moreover, we can say that the measure of angle A is greater than the measure of angle C, or measure of angle A is greater than the measure of angle D. So if the measure of angle C is 40 degree and the measure of angle D is 29 degree, then the measure of angle A is 40 degree. Let's have letter B. If the measure of angle B is 54 degrees and the measure of angle D is 38 degree, then we have to find the measure of angle A. So since 38 and 54 is the angle of this triangle, so we know that the sum of all the angles of a triangle is 180 degree. So 38 plus 54 is 92. 180 minus 92 is 88 degree. So angle C is 88 degree. So measure of angle A must be greater than 88 degree. So as you observe, so you just have to get the greater value of the interior angles. Let's have example number 2. A triangle has two sides that are 6 centimeters and 15 centimeters in lengths respectively. Uno says that the third side could be 10 centimeters. Vince says that it could not be 10 centimeters, but it could be 7 centimeters. Who is correct and why? So by triangle inequality theorem, it says that in any triangle, the sum of the length of any two of its side is greater than the length of its third side. So let's just compare, the two sides of the triangle by its third side. So let's get first 6, 15, and 10 centimeter. So we have there 6 plus 15 is equal to 21. Is 21 greater than 10? That is correct. Next, how about 6 plus 10? That is 16. Is 16 greater than 15? So that is correct. Next, how about the sides 10 and 15? So 10 plus 15 is 25. Is 25 greater than the third side? 6. So that is correct also. Okay, now, we can say that 6 centimeter, 10 centimeter, and 15 centimeter can be the length of the side of triangle. Next, how about the three sides 6, 15, and 7. So 6 plus 15 is 21. Is 21 greater than 7? So that is correct. Next, how about 6 plus 7? 6 plus 7 is 13. 13 greater than 15? That is incorrect. And how about 15 plus 7? 15 plus 7 is 22. Is 22 greater than 6? That is correct. So, we can say that 6 centimeter, 7 centimeter, and 15 centimeter cannot be the length of the side of a triangle. So, who is correct? That's right. Okay, uno is correct. Let's have another example. Example number 3. Given triangle ABC, segment AB is equal to 12 centimeter and segment BC is equal to 17 centimeter. What is the range values of segment AC? So this time we will apply the triangle inequality theorem. So in any triangle, the sum of the length of any two of its side is greater than the length of its third side. So we have this step-by-step procedure. So step 1, we have there 12 plus 17, okay, which is segment AB is 12 centimeter and segment BC is 17 centimeter. 12 plus 17 is 29. Thus, segment AC must be less than 29 centimeter or 29 centimeter must be greater than segment AC. Step 2. By triangle inequality theorem, 12 plus segment AC is greater than 17. So this implies that segment AC is greater than 5. Step 3. Moreover, 17 plus segment AC is greater than 12. So this implies that segment AC is greater than negative 5 and this is not possible because we don't have a side that is negative. We don't have a negative measure of the side. Next, step 4. From step 1 and 2, so we have there 29 is greater than segment AC and segment AC is greater than 5. It implies that segment AC is greater than 29 but greater than 5. Okay, segment AC is less than 29 but greater than 5. So, we can also write that as segment AC is greater than 5 but less than 29. Another shortcut method of this is this one. So, as you observe, 5 is just the difference of 17 and 12. 17 minus 12 is 5. And then, 29 is just the sum of the two sides 12 and 17. 12 plus 17 is 29. So this is the range of values of segment AC. Segment AC is greater than 5 but less than 29. Let's have another example. Example number 4. Based on the diagram below, which car is farther away from the mall? So if we have here the mall, so you have here car A and car B. So we will apply here the hinge theorem. So it says that if two sides of a triangle are congruent to the two sides of a second triangle, and the included angle of the first triangle has a greater measure, then measured than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. Okay, so this side is greater because 100 degree is greater than 90 degree. So, car B is farther away from the mall. Let's have example number 5. Given the figure below, determine the range of values of x. So given this two triangle, so we have segment OP and segment RT are congruent. Segment PE and segment TY are congruent. And we have here its included angle, which is angle P and angle T, which has different measure. So, which side is greater? Okay, so the side opposite the greater angle is the longer side. So we can say that x plus 7 is greater than segment RY, which is 2x minus y. So solving for x, so we have here 7 plus 5 is greater than x. And 12, okay, 7 plus 5 is 12. 12 is greater than x. Or we can write this as x is less than 12. Another, we know that the side of a triangle must be greater than 0. So we can have this inequality. So 2x minus 5, which is one side of this triangle, must be greater than 0. So, by transposition method, negative 5 would become 5. So we have this inequality, 2x is greater than 5. Dividing both sides by 2. So it will give us x is greater than 5 over 2. So the range of values of x is greater than 5 over 2 but less than 12. Okay, that ends our lesson. So you will be given learning activity sheets which you will need to answer. So if you have any questions, okay, so do not hesitate to ask me through our GC. So have a nice day.